Hey everyone, today I'm going over the physics section of the 2019 Invitational Exam for UIL Science. And before we get started, I just want you guys to know that my throat isn't feeling too well today, so please excuse me if you guys can't hear me coherently. I'll get started by showing you all 20 questions on the exam. For the first 4 questions, the first 3 are always from a specific reading, and your year's reading is going to be different, like for every year. So I will ignore the first 4 questions, but the answer, we're going to get immediately started with number 5. An object accelerates at a rate of 285 inches per minute. What is the acceleration in centimeters per second squared? So this is basically just converting between units, and you simply have to know how many centimeters are in an inch, which the answer is 2.54 centimeters in 1 inch, and how many seconds in a minute, which more commonly known, 60 seconds for every 1 minute. So if you want to convert inches to centimeters, the best way I would do it is you want to cancel out inches and replace this with centimeters. That's your goal, right? To cancel it out, right now inches is in the numerator. To cancel out, you need to put inches in the denominator. And now what do you want to replace with inches? You want to have centimeters instead of inches, right? So you have inches in the denominator and centimeters in the numerator. Now just plug in the numbers that correspond to each. So for example, there's 2.54 centimeters for every 1 inch. And just repeat that with minutes. You want to cancel out minutes and replace that with seconds squared. Well, minutes squared and replace that with seconds squared. So first, we know for every 1 minute, there's 60 seconds. And minutes is in the numerator because we want to cancel out the denominator. And because it's minutes squared, we will simply do that twice. So now we got this. And just plugging everything in a calculator will yield us the answer. So when we do all that, my answer was 0.201 centimeters per second squared. So the answer to number 5 is going to be C. For number 6, we know that the ball that's being hit towards Serena Williams is moving at 42 meters per second west. And after it's been hit, it's moving 30 meters per second east. So I'll just quickly draw it out a little bit. So initially it's west, and the racket hits the ball, and it sends it east. And the racket has been in contact with the ball for 0.65 seconds. So we're trying to find the average acceleration of the ball caused by the racket. So for this question, it's just we need one out of the 5 kinematic equations. So I want you guys to go up on Google up the 5 kinematic equations, and try to find out which one we would use for this situation. It's actually, I'll give you a hint, it's one of the smaller ones. So just pause the video and try to find that. Once you find that, I'll just reveal it to you right now. Final velocity equals initial velocity plus acceleration times time. This is the equation we'll be using for this question. Now, what is initial and final velocity? Well, we know initially it's been traveling 42 meters per second west. Mathematically, we think of right and up as positive. We think of down and left as negative. So when you're moving west, you're moving to the left. So we would think of this as negative. Note that it doesn't really matter like what you choose, a negative, positive, you'll actually get the same answer either way. But just be sure, whatever you choose this, you would have the opposite sign for the east. So for west, I'll just choose negative. So you're moving negative 420 meters per second initially. So final velocity equals negative 420. Oh, I mean 42. Now what is the final velocity? Oh, plus 18. Final velocity is 30 meters per second east. East is positive. So this is going to remain 30. So I will replace VF with 30. And now we're also given the time it took, like the ball, to change speeds. So the time was 0.65. And now just simply solving for acceleration will give us 110.769, which will round up to 111 meters per second squared. So answer to number 6 is E. For 7, while cleaning the library, Belle pushes a 21 kilogram box of books across a frictionless floor. She pushes with a force of 35 newtons angled downward at 20 degrees below the horizontal. What is the acceleration? When we get to any problem revolving like forces, I want you guys to draw out the whole problem. So we have a box on a floor. Make sure to note that the floor is frictionless, which is very important and will save up a lot of math in this problem. And you're pushing downward at 20 degrees below the horizontal. So let this line right here be the horizontal. You're pushing, and this is the angle we're pushing at. This angle, I'll actually draw that a little bit better. Right here. This angle right here, that is 20 degrees. And now the force, we're pushing with 35 newtons of force. So we're trying to find acceleration of the box, and we're also given the mass. By Newton's second law, we know force equals mass times acceleration. Rearranging that, we'll get acceleration equals force divided by mass. We know the mass, and we know the force, right? 35. We're angled. We're not, that's not 35 newtons straight into the box. We can break up this vector into two components. We can break it up into, let's just say, this horizontal component and this vertical component. When you're pushing a box and you're pushing straight down on the box, is the box going to move? No. You're pushing straight down on the box, guess what? The box is pushing straight up. In fact, there's actually two concepts I want to get into right now. There's the weight of the box and the normal force the earth pushes on the box. But that concept doesn't really matter now because there's no friction. In a case with friction, I might go over that in another video where, yeah, they will add friction, but now that there's no friction, we don't need to worry about all that. Just note that the vertical component right here, that does not matter. What matters is the horizontal component. How do we find that? Let's redraw the triangle. This is 20 degrees, and we know the hypotenuse is 35. So, and we want to find this. By using trigonometry, we know the cosine of 20 is the adjacent divided by the hypotenuse. That means the adjacent is just 35 times cosine of 20. Plugging that into a calculator, you're going to get 32.889 newtons. Now we know the force. So acceleration equals 32.889 divided by the mass of 21. Your final answer will be 1.566, which was closest to option C. So answer to 7 is 1.57 meters per second squared. For number 8, we want to find the average power output for Gaston. If he exerts a force of 320 newtons across 5 kilometers in 30 minutes, how would you calculate his power output? This just involves two formulas. Power equals the work divided by time. And work equals force times distance. So how are we supposed to solve this problem? You might think, okay, this is just multiplication, division, and yes, but keep in mind the units. That's probably the only one of the big ways someone might trip up on this question. Force is standardized with newtons. I think almost every equation you'll have to deal with deals with force in newtons. Distance, 99 times out of 100 is in meters. I think there's a few that have centimeters instead of meters, but like most of them, especially in the physics section, you'll deal with meters. And time, you will almost always deal with seconds. Memorize these three like standardized, and you're pretty much good for any like equation, and especially in the physics section. So to calculate work, 320 newtons. We want to convert the distance 5k into meters. 5 kilometers is the same thing as 5,000 meters. So you're going to get 320 times 5,000. I'll just write that in scientific notation right here, but you will get the same answer. Oh, that's in, but by the way, the unit for work is in joules, because work is a change in energy, and energy's standardized unit is joules. But we're trying to find power. So we're gonna divide this 1.6 times 10 to the 6th, and we have to divide it by time. So we want time to be in seconds. So 30 minutes converted to seconds, you just multiply 30 by 60. So just solving everything, you would get a power of 888.88, or pretty much 8 infinite, which rounds to 889. So the answer to number 8 is 889 watts. And remember, the unit of power is watts. For number 9, a meter stick is hung horizontally with a pivot exactly at the stick's center of mass. A 150-gram object is attached to the meter stick at the 30-centimeter mark and is balanced by another object attached to the 90-centimeter mark. What is the mass of the unknown object? So again, we'll just draw out this problem. We have draw out a vertical bar, and the meter stick is hung horizontally to this bar. We know a meter stick is 100 centimeters, so we have to just keep that in mind, like with like the different numbers we have here. So we have a 150-gram object at the 30-centimeter mark. So let's just say this right here, 30 centimeters. We have 150 grams. And we have another object at, one sec, I'll say this is 10 centimeters away from this end, which means 90-centimeter mark. And we're trying to find this one. This problem involves torque. Torque is basically just rotational force. And the formula for torque is force times the radius away from the object. If you want to go into more complex problems, you would have force times radius times sine of theta, and theta is just the angle between the radius and the force. But in this case, the radius and the force form a 90-degree angle, and sine of 90 degrees is just 1, so we don't need that right now. So we know what force is, but what is radius? Is it like the radius of a circle? It's actually a little different. Radius is the distance between the center and where the force is being applied to, right here. So in this case, the force is being, like, I'll draw the force vector in blue. The force vector is the blue vector. The radius is the distance between the axis intersection and the blue vector. Again, I'll draw the green vector with the unknown object's weight. The radius is simply a distance between the axis and the force. So let's calculate the torque for the first object. So we know the force. What is the force, first of all? We know the object weighs 150 grams. Weight equals mass times the acceleration due to gravity. And remember, mass is standardized in kilograms, not grams. It's like I think the only exception to the rule of like everything has to be in without any prefix. Mass, most people use kilograms in physics. So that's 0.15 times 9.8. You would get 1.47, and don't forget the unit of weight, newtons. 1.47 newtons times, now what's the radius? Well, we know if this entire section is 50 centimeters, and this part over here is 30, the pink line has to be 20 centimeters. So just 20 centimeters. So the radius is 20. Multiply that, you would get 29.4. Now, what about on the other side? One more thing is that since the object is finally balanced at the end, that means there has to be no net torque. So the torque 1, which I'll just call that, minus the torque 2 has to be 0, which means torque 1 has to equal torque 2. So torque 2, which is the torque on this side, has to pretty much be equal to 29.4. So 29.4 equals force times radius. Well, we don't know the mass of the objects, we don't know the force applied, we're trying to find that out, but we do know the radius. Well, we know if this is 10 centimeters, that means the orange line has to be 40 centimeters. And centimeters to meters, you want to always convert that to 0.4. Actually, now that I just realized I made a mistake here, I forgot to convert this to meters. You would get 1.47 times 0.2. This should actually be 0.294. So 0.294 divided by 0.4. The force displayed by the object should be 0.735 newtons. Now, we want the mass of the object, not the force it applies. Well, we can use the same formula. Weight equals mass times gravity, acceleration due to gravity. 0.735 equals the mass of the object times 9.8. And divided by 9.8 from both sides, you will get 0.075 grams as the mass, or 0.05 kilograms as the mass. So converting that into grams, you get 75 grams. So the answer to this question is going to be D, 75. For number 10, we know that a 500 gram mass is hung from a spring. When it's pulled and released, the mass on the spring oscillates with a period of 0.39 seconds. And we're asked to find the spring constant of the spring. So the formula we need to use in this equation is going to be period equals 2 pi times the square root of the mass divided by the spring constant. This is it is a little bit of like equation most people you'll learn in AP Physics 1 a little bit, I think mid to late in the semester, but this equation is very important for this and a lot of other ones for Physics C. You're going to need to memorize this. So we're asked to find the spring constant K. By plugging in the numbers, we can pretty much achieve this. So the period is 0.39. The mass, remember we want to convert this to kilograms, 0.5 divided by K. And just solving for K, so 0.39 divided by 2 pi squared. If you did the math right, you would get 129.778, or yeah, 778, which is very close to 130 newtons per meter. So the answer to this question would be A, 130. For For number 11, we dive into a vat of cooking oil, which has a density of 0.91 grams per centimeter cubed, to retrieve our cell phone. And the depth of the oil is 3.8 meters. So we're trying to find gauge pressure at the bottom of the vat. So one thing we need to know is, what is gauge pressure? Gauge pressure is simply the pressure of a fluid only. Normally we think of pressure, we think of the pressure of the fluid plus atmospheric pressure. That's the total pressure. But when we're asked to find gauge pressure, we're just finding the pressure of the fluid. When I ask you for a total pressure, we add this to the atmospheric pressure. So, how do we go about solving this? The formula for pressure is density, which is like represented in rho. I'm not sure how to draw that, but rho times the times the depth or height, pretty much, times the acceleration due to gravity. So I'll just write them out. Pressure, density, height, acceleration from gravity. So plugging in the numbers, we know that the density is 0.91. But one thing I want you guys to know once again is, look at the units. Grams and centimeters, neither of them are the standard physics units, so we need to convert that. So 0.91 grams for every 1 centimeter cubed. How do we convert grams to kilograms? For every 1,000 grams, we get 1 kilogram. How do we convert centimeters to meters? For every 100 centimeters, we get 1 meter. And because it's centimeters cubed, we're going to do that 3 times. So plugging this, by the way, this is only to find rho. Plugging that entire equation in will get you 910 kilograms per meter cubed. So pressure equals 910 times, what's the height? The height's 3.8, and what acceleration to gravity is always 9.8. So now we got the gauge pressure. 910 times 3.8 times 9.8. We got the gauge pressure is 33,888.4. What is the standard unit of pressure in physics? In chemistry, you might have used ATM a lot. In physics, the standard unit is a Pascal. So this is the gauge pressure in pascals, but we want to convert that to ATM. So 88.4 pascals. If you remember from chemistry, 101.3 kilopascals equals 1 ATM. And kilopascal is basically 1,000 pascals. So I'll rewrite that as 101.300 pascals. So plugging that in would yield you 0.334, or I'm going to rewrite 0.3345 ATM. So it's closest to answer choice B. So the answer to this question is 0.335 ATM. For number 12, we have 2 resistors, 27 ohms, 47 ohms. They're placed in series and connected to a 12-volt battery. And we're trying to find the current passing through the 12-ohm resistor. So this one you're going to have to go a little bit into circuits, but luckily it's a series circuit. It's relatively a little bit simpler. In a series circuit, which means that everything is connected in one straight path, so I'll draw it out. Say the battery, you have the positive and the negative terminal. Or I'll draw the conventional. You have 2 resistors. So you have one resistor is 27 ohms and one resistor is 47 ohms. This is a 12 volt. So in a series circuit, all the electrons in the circuit are going in one direction. I mean, they're all going through the same path. There's no alternate pathway these electrons can take. So in this case, we know the current going through each resistor has to be the same. So we know the current. Now we know that the current going through each resistor is the same. That saves us a lot of work. What is said current? We're going to use Ohm's law for this question. Ohm's law states that voltage equals current times resistance. So we can rewrite that as current equals voltage divided by resistance. But there are two resistors. How would we find resistance? Do we just divide voltage by each resistor? That won't work because we'll get different currents, and we know that in series the current has to be the same. We can technically find the total resistance, and here's how to do it. In series, the total resistance is simply the sum of all the resistors in the circuit, which is why series is really pretty simple. Parallel, once we get to parallel circuits, it's a little bit weirder, but it's also somewhat straightforward. So the total resistance is just 27 plus 47. So 74 ohms. So current equals 12 volts over 74 ohms. You're going to get 0.162 amps. Our answer has to be in milliamps, so simply multiply 0.162 by 1,000 to get 162 milliamps. And if you guys didn't know, just remember the standard units for voltage, current, and resistance. Voltage, the standard unit is volts. For current, the standard unit is amps, or amperes, technically. But we'll shorthand that for amp. And resistance, the standard unit is ohm. For number 13, we know that a balloon holding a charge of negative 12 nanocoulombs is placed with its center 45 centimeters from the center of a Van de Graaff generator with a charge of 90 microcoulombs. We're asked to find the magnitude of the electric force. So some key equations you want to know is Coulomb's law, which states that force equals Coulomb's constant times the first charge times the second charge divided by the radius squared. So before that, I just want to let you guys know what the meaning of these signs are. So in this scenario, we don't really care too much about the signs because it's only asking us the magnitude of the electric force. But a positive and a negative charge, since they have opposite signs, the forces would attract. So the force between the two charges would push them together. But in this case, we don't need to know that because it's only asking us for magnitude. So we can actually ignore the signs for the math. So plugging in all these constants in, remember you have the constant data sheet underneath on your packet, which in this case, the physics constants. Coulomb's constant right here, 8.99 times 10 to the 9th. We can calculate that to be force equals, I'll just use 9. 9 times 10 to the 9th. What's the first charge? The first charge is 12 nanocoulombs. Again, I'm ignoring the negative sign. Nano means 10 to the negative 9. What's the second charge? 90 microcoulombs. Micro means 10 to the negative 6. So definitely make sure to memorize what nano and micro mean because these are very important and they'll be showing up multiple times on these exams. And then the distance is 45 centimeters. So remember the standard unit for distance is in meters. Convert that to 0.45 squared. and just plug everything here in. You should get a force of 0.048 newtons. So your answer to number 13 is C. For number 14, we're shown that a beam of electrons is moving at a velocity of 4.5 times 10 to the 5th, directed into a region with a perpendicular magnetic field. If the electron traces at a region with a radius of 22 centimeters, what is the magnitude of the magnetic field? So we'll start off with some important formulas you guys will have to know for this one. Let's start off, for one thing, we know that electrons are tracing out a circle with a radius due to a magnetic field. Why are they tracing out a circle? It's because the magnetic field is exerting a force on these electrons to cause it to form a circle. And what kind of force is involved with objects moving in circular paths? Centripetal force. So the formula for centripetal force is the mass times the velocity squared divided by the radius. So initially we look at this stuff and we realize, we don't have everything yet. Because obviously we know velocity, we know radius, and we can find the mass, but again, does that account for the fact that we're using a magnetic field for it? No. And that doesn't even give us the value of the magnetic field. However, we know the formula of a force, of a current going through a wire. Because remember, current is just the flow of electrons. We can still use that kind of relationship here. The force of current going through a wire is I, current times length of the wire, times the magnetic field going through the wire, times sine of the angle between the wire and the magnetic field. But in this case, it's a perpendicular magnetic field. So sine of 90 degrees is just 1. We can ignore that part. One thing I want you guys to know is what is current and what is length. So current is basically the flow of charges per time. So we can write that as charge per time. Length, this is probably much more common, but length we can essentially equate that to distance, and distance is just velocity times time. Velocity times time, and we'll leave the magnetic field constant. So canceling out the times, you're going to get magnetic field times charge times velocity. So we got a new formula. Now, we know that the force, the centripetal force, is caused by the magnetic field. So these two are equal. So mv squared over r equals bqv. Now we simply have to solve for B, which is the magnetic field. So B equals mv squared over rqv. And dividing 1v on both the numerator and denominator would give us mv over rq. So now we can plug in all the numbers here. We know the mass of an electron. We know the velocity that's given to us. We know the radius that the electrons are tracing. And we know the charge of an electron. I'll pull those up real quick. So the electron mass is given to us as 9.11 times 10 to the negative 31. The velocity was given to us as 4.5 times 10 to the 5th. The radius was given to us as 22 centimeters, or 0.22 meters. And the electron charge, actually I'll circle both for you guys, is the same as the fundamental charge, except that it's negative, but in this case, that's the sign doesn't matter. So just plugging these 4 values in will give us the answer. So we get a value of 1.163 times 10 to the power of negative 5. But here's the thing. We're asked to, and this is in Teslas, by the way. That is a standard unit for magnetic field, Teslas. But we're asked to find the unit in microteslas. Remember, micro is equal to 10 to the negative 6 of the normal unit. So in this case, we want to convert Teslas into microteslas. So Teslas into microteslas. We know 10 to the power of 6 microteslas for every Tesla. For every 1 Tesla. So that is simply, once we calculate that, you'll get 11.63 microteslas. So the answer to this question would be B. For number 15, a light traveling in air enters an unknown liquid at an angle of 45 degrees with respect to the liquid surface. The refracted ray makes an angle of 56 degrees with respect to the liquid surface. What is the index of refraction of the unknown liquid? So what we need to use for this question is Snell's law, which states that the index of refraction for the first surface times sine of the angle that the ray makes with the horizontal equals index of refraction 2 times the sine of the angle that the refracted light makes with the horizontal. And wait, no, my bad. I meant vertical for both these. Do not use the horizontal. That will trip you up in this question. So what is the vertical? Actually, it's most people call it the normal line. It's basically just perpendicular to the surface. So I'll draw that in pink right here. This perpendicular line to the surface, we're measuring our angles in respect to this line. So obviously the angle for 45 degrees will stay the same, but this angle between the ray and the pink line is 34, because 90 minus 56 is 34. So now that we know that, and n is basically just the index of refraction. So the index of refraction for air is just 1. So we know n1 is just 1. And the angle that the light through the air makes is just 45 degrees. So we can write that, 45. n2 is what we're trying to find. And we know that the refracted angle makes a 34-degree angle with the vertical line. So solving for n2 will give us 1.264. So the answer to this question is going to be C. For number 6, a converging lens is used to form an image of a neon sign. The sign is 2.2 meters from the lens, and the focal length of the lens is 80 centimeters. At what distance from the lens is the image formed? So the only important equation you'll need for this question is going to be this one. 1 divided by the focal length equals 1 divided by the distance of the image plus 1 divided by the distance of the object. And keep in mind that when I said that meters is the standard unit of distance, this is actually one of the few exceptions. So we're actually going to be using centimeters for each of these values. So the focal length we know is 80 centimeters. We're trying to find the distance that the image is from the lens. and the object is 2.2 meters or 220 centimeters. So just plugging all the numbers into your calculator, you would get a distance, the images from the lens, you would get that to be 125.714 centimeters, which is equal to 1.257 meters. So that's closest to option choice D, 1.26 meters. For number 17, we have a hydrogen atom is excited to the n equals 5, the 5th electron level, and it transitions into the 3rd electron level. We're asked to find the wavelength of the photon emitted. So the equation we will need for this problem is the Rydberg equation. There are actually two forms of it, and I think this does trip a lot of students up, is the fact that they use the wrong constant for the form when they should have used the other constant. So the two forms are 1 equals lambda, or wavelength, 1 over wavelength equals Rydberg constant times 1 over the final level squared minus 1 over the initial level squared. The other equation is the exact same, except we have energy instead of 1 over lambda. And the difference is that they use different constants. So the constant we get on the chemistry worksheet up here, the one that says joules, that's referring to the energy one. The one that gives you, the one that says m to the negative 1, that's referring to the wavelength one. So make sure to know which constant you're using. For this problem, I'll use the first variation of the equation. So we're plugging in the Rydberg constant. The final level is 3, so 1 over 3 squared, minus the initial level is 5, so 1 over 5 squared. So just plugging all these numbers into the equation. I got 1 over lambda equals 78,008.889. Taking the reciprocal of that, you would get 120 or 1.28 times 10 to the power of negative 10 to the negative 6. We're trying to convert this into nanometers, right? So to convert, and this is in meters, by the way. Our answer is in meters. To convert it into nanometers, we multiply it by 10 to the power of 9. So the final answer, if you multiply this number times 10 to the power of 9, you would get 1281 nanometers. So actually I got 1281.9 nanometers, so that would be closest to B, 1282. So the answer to number 17 would be B. 18 is our quantum question, a quantum dynamics question. And we're asked to find what is a meson composed of. Mesons are composed of a quark and an antiquark, and are not to be confused of baryons like our protons and neutrons. Baryons are our baryons are composed of 3 quarks. So do not get that confused. So the answer to this question would be C. For 19, we are dropping an object at rest, and we're trying to find a graph that relates the final velocity once it reaches the floor to the initial height of the drop. For this problem, we will be using one of the 5 kinematic equations that I talked about in the beginning of the video. So just take a moment to think which equation we will be using for this question. The answer is this one. final velocity squared equals initial velocity squared plus 2 times the acceleration times displacement. So as we're dropping the object at rest, there is no initial velocity. So we can rewrite as something like this. And acceleration is solely due to the weight of the object. It's solely due to the gravity that Earth is exerting on it. So this is the equation we get. And to take it one step further, we can take the square root of both sides to get the final velocity equals square root of 2 gd. So we know 2 is a constant, obviously. And the acceleration due to gravity, since you're on Earth, you're not changing that. That's also constant. These both stay the same for the entire experiment. D is the only thing that doesn't. So we can actually group square root of 2g as its own thing and square root of d as its own thing. And this becomes some constant. Let's just call that k. So you get final velocity equals k times the square root of d. Now, if you guys don't know how to get it from here, just think about your parent equations in your algebra class. How would a graph that looks like this look like? It would look something like this, right? Like almost like a plateauing line. That's exactly what this graph pretty much is. So the only option that looks like something like this would be A. For number 20, it's going to be our graph question. And we are told that the resistance of a wire is measured as a function of its length. And based on the data, you know that the diameter of the wire is 0.4 millimeters. We're asked to find the resistivity of the wire. So we know the resistance equals the resistivity, which I'll just put as lowercase r, but there's another symbol for that. Actually, now that I think about it, I think it's a rho, times the length of the wire divided by the area, the cross-sectional area of the wire. So what is resistance? Actually, in this case, there are actually two ways you can do it. The first way is you can find resistance divided by length. That is pretty much the slope of the graph, because slope is equal to y over x. And then you can solve it like that, where you take 2 points and find the slope. For us, there's this one point over here that's like dead on like 2 different lines. So we can just use this and save a bit of time. If that's not the case, I would recommend finding the slope, because I think that the exam tries to make the slope a little bit closer to the answer. So find a point if you are 100% confident of the values. If not, just take the slope of the line. In this case, I'll just use the point. So we know 50 meters leads to 60 ohms. So just plugging those values, 60 equals resistivity times 50 over area. And we know the diameter of the wire is 0.4 millimeters. We're asked to find the area, the cross-sectional area, so basically the area of the circle. So the diameter is 0.4 millimeters. The radius is 0.2 millimeters. Or 2 times 10 to the negative 4 meters. So using the area equals pi r squared formula, you would get 126 times 10 to the power of a negative 7. So plugging that in the bottom, you would get 60. Actually, I'll just solve for rho. 60 times 1.26 times 10 to the negative 7 over 50. You would get roughly 1.507 times 10 to the power of negative 7. So the answer would be the closest to this value, which in this case would be D. And for questions like this, you might see like we got 1.5 and the answer is 1.4. It's because we use the actual point, whereas the test wants you to use a line. Like I said, if you're only dead certain the point is the accurate one, I would use it. In fact, we're only lucky because the values are decently spaced out. In other times, I would say just use the slope, but even the slope can get inaccurate because now you have to use 2 points and you want 2 points to be completely accurate. So it's really just like choose your preference, but both ways, like, just got to do the math right and you will get close to the right answer. All right, that's the last question of this exam. Feel free to put in the comments any questions you've had. And once again, I apologize for my voice. I just had a bit of a sore throat today. But yeah, just let me know like what doubts you have, and I will be ready to clarify. And if you want, you can check out my schoolhouse sessions that I'm hosting every Saturday, where I review biology, chemistry, and physics concepts that will help you a lot on this exam. I hope all of you have a great rest of your day.